So good evening, everyone. Someone of you please tell me whether my slides are visible and audio is clear.
Yeah.
Hello.
Yeah. Both are okay. Audio is clear. We can see your slides.
Hello.
Hello?
Hi. Yeah, my voice is clear and the presentation is visible.
Yes, yes.
Slides are changing, sir.
Yes. They are changing.
Okay. Okay. So extreme precipitation and floods. Instead of taking theory about extreme precipitation and floods, we have a very good case study about extreme precipitation and flood, which has been carried out by Nikunj as my student, Samtech student, and based on his dissertation studies, we have published a paper on it. So basically, I am going to discuss the extreme precipitation, and because of that, the flood which has generated in the Banas river, which resulted into loss of life as well as damage is worth lakhs of rupees. So flow of presentation is like this. As we all know, the definition of flood and the losses caused by the flood since last 4 days, we are discussing that only. So I'm not discussing any of the part regarding what is flood, what is 1D, 2D, 3D modeling, what are the limitations of floods, etc. What I am going to talk about is in July 2017, India witnessed a series of flooding due to excessive rainfall in the monsoon season. And in 2017, not only one state, but states like Assam, Gujarat, Rajasthan, Odisha, Madhya Pradesh, Tripura, and West Bengal were flooded in many parts, which lead to the loss of life of hundreds of human and several animals, and also cause extensive damages to the infrastructure. Basically, the event which I am going to talk about is the region which were not flood prone earlier. It's basically the region which I am going to talk about was a semi-arid region, and the annual average rainfall, if you will look at the annual average rainfall figures of the area of last 100 years, that figure is very small, are also facing but now these regions are also facing, since last decade, these regions are also facing floods. For example, the semi-arid region of Gujarat, that is northern part of Gujarat, Aravalli, Banaskantha, Gandhinagar, Mehsana, Patan and Sabarkantha, was affected by severe flooding during July 2017 due to heavy rainfall. In view of the severe impact of flood, it is necessary to study and improve the scientific understanding regarding the phenomenon of the flood. So where this happened? So it was Banas river. This Banas river, as I said, it's in the northern part of the Gujarat, and one of the two major west flowing river having total basin area of 6,112 kilometers square flooded in July 2017. The Mount Abu, Deesa, Banaskantha and Dantiwada regions of the catchment received rainfall of 1,473 mm, 269 mm, 150 mm and 490 mm respectively within 48 hours. Dr. T, I'd like to draw your attention that the Mount Abu, which has received 1,473 mm of rainfall in 48 hours, was having return period of 1 in 100 year. 1 in 100 year return period rainfall that has fallen in 48 hours over the Mount Abu, and from where the Banas river is originating. So one thing is that the heavy rainfall from where the river is originating. Not only that, the river is passing through the Deesa, Banaskantha and Dantiwada. These region also received a very heavy rainfall during the same period, which was of 269 mm, 150 mm, and specifically Dantiwada region, which has received 490 mm of rainfall in 48 hours. That is from 23rd July 2017 and 24 July 2017. While
Was this
the annual
monsoon
average
related
rainfall,
event?
no,
Was it related a cyclone related event or?
yes, I'm coming to that. I'm coming to that.
Okay.
While the annual rainfall of the basin is 921 mm. So look at the figure. The annual rainfall of basin is 921 mm. While the Mount Abu itself received 1,473 mm of rainfall in 48 hours. The historical data shows that the rainfall occurred on 23rd and 24th was the maximum of the past 112 years. Why this happens? That we will see. So, in addition to it, Mount Abu being hilly region produced high runoff, which resulted in filling up of two dams. There were two dams. I am going to show you the line diagram of it. Dantiwada and Sipu up to its FRL rapidly. Rapidly in the sense less than that of the 24-hour of time period. The dam was filled up to rule level due to local rainfall. These circumstances forced the dam authorities to make a decision of sudden releases from the dam. The basin is having such characteristic, the depth of river and carrying capacity decreases from downstream of the confluence of the river. Because of flat topography and low laying carrying capacity, the water in the downstream region has tendency to spread in the lateral direction, which resulted in severe flooding. So, you can see in this figure the contour map of the study area, wherein this is the Mount Abu region, that is hilly region you can see here, which has got the very heavy rainfall 1,303 mm, and as you move further, right, that is a direction of flow. This is again a direction of flow. There are two dams here. You can see that this is one tributary which is again originating from this hill, Mount Abu Hills, which has received 1,303 mm of rainfall. This is another tributary, right, which is Sipu river, and this is the Sipu dam. Somewhere here is a Sipu dam, somewhere here is a Dantiwada dam, and both the tributaries confused here, which is approximately 8 to 10 kilometers from Sipu dam and 8 to 10 kilometers from that of the Dati dam. This will be more clear when we'll be looking at the line diagram of it. So in addition to it, in this region, there is a Narmada Main canal, which has been constructed perpendicular to river flow, which has obstructed the flood water and resulted in an increase of flood inundation depth in the upstream region. The canal was also breached at various locations near Thara village, which causes more damages in the downstream region. The flood have impacted lives and livelihoods, including education and public transportation, by damaging roads, highways, railway lines, airports. From the survey results, total payable relief for agriculture, horticulture, cattle and land damages stands 1,653 crores, and approximately 200 human lives were lost during monsoon 2017. Yeah, there was one incident also that 18 members of the same family killed. That is in Kharia village in the Banaskantha. 5 national highways, 156 state highways, and other 550 roads under Panchayat were affected due to this particular flood. So analysis was carried out to find out what can be the mitigation measures for these specific reasons. But before that, I am showing you some of the pictures of flood inundation due to Banas flood in 2017. These are some another pictures. This is one village, Umri village, and you can see the houses are all kacha one, and the water level, depth of water you can see here in this picture. Similarly, there is another village, Abhyana, and this is the depth of water in the Abhyana, approximately 7 feet, that is 2.1 meters. This is the breach portion of Narmada Main canal, and these are the army people who have been deployed to rescue the people from the villages. This Banas river, as I said, that rises from Pindwara village in Siroi district of Rajasthan, at an elevation of 372.5 meter. The total length of the river up to run of Kutch is 266 kilometer. The drainage area is 8,674 kilometers square, which passes partially from Gujarat and Rajasthan. The Luni Basin in the north, Saraswati Basin in the south, and Aravalli Hill regions in the east, and finally the Arabian Sea in the west. That has been bounded by the Luni region. The average rainfall in the Banas Basin, as already have discussed, 921 mm. This is the study area for which the analysis has been carried out. You can see here, this is a hilly portion from which this river originates. It's a one tributary. This is a one dam, that is Dantiwada dam. This is another tributary wherein you have Sipu dam. This is the confluence of it. This particular is a Ubri gauging station where you can measure the discharge, and this is Kamalpur gauging station, which is on the downstream side, almost near the end where the river enters into the run of Kutch. Near that, these two gauging sites are there for the measurement of discharge. The villages we were talking about was Deesa. This is one of the worst affected taluka place. It's not neither village nor city. It's a taluka place, and this one was the town which was worst affected, and it was just near the confluence of the Sipu river and the Banas river at near Deesa. So let's see what happened. So without going into the details of rivers, yeah, this is the line diagram of origin of Banas river. You can see here from here that there are number of dams. Kalumbari dam here, then here is Sarup Sagar sluice, that is there, that is confluencing it with it. Again Swarupganj dam, then Saroti rain gauge station, Balundra rain gauge station. There is another tributary of Balram river which has Chitrasani rain gauge station, and measuring these two, that is Balundra rain gauge station and Chitrasani rain gauge station, the discharge which is inflow into the Dantiwada dam, that can be computed, but the lead time for the flow to reach from Balundra to Chitrasani to Dantiwada dam is less than 4 hours. Then the other tributary, that is downstream of Dantiwada dam, and the other tributary which is joining it, that is Sipu river. That Sipu dam is located at 12 kilometers from the confluence of this river and Banas river and that of the Sipu river. While the further the Banas the river flows downstream, wherein we have one gauging site, that is Umri, and another gauging site, that is Kamalpur. The left bank tributary, right bank tributary is Khari river, while the right bank tributary is also known as Khari river 1 and Khari river 2. Ultimately, this river ends into Little Run of Kutch. So what exactly happened on the day? This is basically a semi-arid river, and this is the data wherein it shows what is the monthly average rainfall of this particular that is Deesa station, Deesa IMD station, and as I said that the rainfall is 578.8 mm, while the evapotranspiration is 1886, which makes this region arid, as the aridity index comes out to be 0.31. And the Narmada Main canal, which is flowing perpendicularly, we'll see later on that how it has obstructed the flow. The there is one canal siphon also which was made on the Banas river, which is allowed to pass the flood discharge through it, and at that chainage how much flood discharge it can pass, that is also given in this, that is 387 cumac or 13,683 cusec. So Narmada Main canal is perpendicular to that of the flow of Banas river. I'll show here in this map. Yeah, this is my Narmada Main canal. It's a contour canal, and it is passing perpendicular to that of the Banas river. And somewhere over here, this canal siphon is constructed. This canal siphon, which was constructed, was having approximately in length or width as 700 meters, approximately 700 meters to 1 kilometer. So that was given over here, that this is from this channel to this channel, and the discharge which can pass in between this, between the canal siphon, is around 13,683 cusec or 387 cubic only. So this is a complete line diagram. Here is Banas river. From this side, the Sipu river comes. This is a Dantiwada dam. This is Sipu dam. The river confluences Sipu and Banas river confluences at approximately 12 kilometers from Sipu dam, 13 kilometers from Dantiwada dam. This is the Umri gauging station. Yeah, and this is Narmada Main canal, which is perpendicularly crossing the Banas river, right? And finally, the river confluences into after Kamalpur gauging station in later run of Kutch. This is a picture of view of the river of Sipu dam and the view of the river of Dantiwada dam. This is the condition of the river. You can see from here that the near the Deesa bridge. So from the level difference, the vegetation around and the depth of the river. This is after the dam, downstream side of the dam. This picture is taken downstream side of the dam, and you can see the depth of river is almost negligible or very less compared to that of height of the bank and depth of the river. This is a Nikunj. He is also attending this particular GAN course, and he has visited this entire study area and collected the real-time data after the 2017 flood damages. So this is another picture of the bed of the river near Mota Jampur village. This is another picture of the river bed near Abhiana village. Then the data sources, what data we have collected, I'll not go into the detail of it, just I will show in a table that flood hydrograph of Dantiwada Dam, Dantiwada Dam Authority, flow hydrograph of Sipu Dam from Sipu Dam Authority, stage and flow hydrograph at Kamalpur gauging station from CWC, stage and flow hydrograph at Umri gauging station that we have collected from Rain Gauge Section Office Palanpur, flow hydrograph of Narmada Main Canal at Banas that we have collected from SSNL Gandhinagar, and actual flood inundation depth and extent that we have carried out questionnaire survey, and from the flood mark HFL we have worked out the flood depth in the various villages on either side of the bank. So the flow methodology adopted in this was identifying the causes of 2017 Banas river flow that we will discuss first. Then we have collected the data. We have developed 1D hydrodynamic model. We have developed 2D hydrodynamic model, and integrating 1D and 2D hydrodynamic model using MicFlood software. We have worked out the simulated depth. That simulated depth we have validated and calibrated by actual observations, identifying effect of canal on flood inundation also. So hydrological aspects are what you were asking about, what has happened in case of monsoon. So during the monsoon season 2017, total 14 low pressure systems formed over the Indian subcontinent. Sir, what you were asking about why so much of rain has fallen. So in India, the seasonal winds are blowing from Arabian Sea and Bay of Bengal, bring heavy precipitation during the month of June to September. According to the Indian Meteorological Department, this period is known as southwest monsoon season. It is the principal rainfall period for the Indian subcontinent, and country receives 75% of total rainfall during the southwest monsoon. During the monsoon season of 2017, 14 low pressure systems formed over the Indian subcontinent, and that has resulted in and when a comparative analysis is made, month-wise frequency and intensity of low pressure systems as per the record of IMD 2017, these are the number of depressions formed over the system. And in case of July, the total number of this frequency and intensity of low pressure system were 6, which has resulted into what you can say the heavy rainfall. In July 2017, part of Gujarat and Rajasthan have received heavy rainfall because of these formation of depressions. Low pressure regions develop frequently over the Bay of Bengal and moves west or northwest, drawing rain to the northern region of the country. But in 2017, the pattern has been strange and unpredictable, with 2 separable depressions present at the Arabian Sea and Bay of Bengal at the same time. So the rain clouds have approached from 2 sides, one from Arabian Sea and another from Bay of the Bengal. So in the second week of July, a depression developed over southeast Uttar Pradesh and traveled to Gujarat across Madhya Pradesh, leading to heavy rains and floods at that time. Another system which was developed around Odisha. Uttar Pradesh is in the north part, sir, while the Odisha is in the south part, that is southern part of the country. So 2 pressure systems, one from the Uttar Pradesh traveling towards the Madhya Pradesh, reached over the Gujarat, and another one from Odisha, that is from south part, that has moved and reached over the Gujarat 21st and moved to Gujarat via Andhra Pradesh, Telangana, and Madhya Pradesh. So this system caused rainfall around Morbi and Surendranagar district of Gujarat till 23rd. So this system has developed on 21 and continued rainfall till 23rd. So this has resulted into extreme rainfall. It was supposed to dry down and move towards west within 3 days, but it could not move ahead because of the second system approaching from Madhya Pradesh. The normal monsoon pattern was the depressions that developed in the Bay of Bengal would travel northwest, but for the last 5 years, it started to travel in west. So, unlikely historically, when the onset of monsoon caused by either an active system emerging from Arabian Sea or Bay of Bengal, lashing heavy rains in the year 2017, both the system have been active and caused simultaneous low pressure over Gujarat. So what further aggravated the scenario is the merger of these 2 active systems lasted for more days than usually seen in other cases of flooding, such as in Assam 2017 and Chennai 2016, and resulted in heavy rainfall again from July 25th till 27 in Banaskantha, Sabarkantha, Patan, and Gandhinagar. The recorded rainfall at various IMD rain gauge stations in Gujarat is shown in the table with normal rainfall and all-time highest recorded rainfall. According to the IMD data, between July 1st to 28th, Gujarat has received excess 65% rainfall at 559.4 mm as against the normal rainfall of 339 mm for the same period. Area-wise, highest rainfall has been witnessed by Banaskantha, Patan, Gandhinagar, Morbi, Surendranagar, Mehsana, and Sabarkantha in order of 267%. This Banaskantha, the study area region, has received 267% more rainfall than that of the normal rainfall during this period. That is 208%, 189%, 174%, 172%, 130%, and 115% respectively. So this is the table which shows what is the normal rainfall and what is the rainfall in the month of July and what is the highest recorded rainfall in July. So if we talk about Deesa, so normal rainfall 226, which has been 950 mm, right, which was the highest recorded was 965 in 2015. So this is the system, Dr. T, what you were asking about. Hello, sir, are you there? Okay, so one system is approached.
Yeah, I'm there. Sorry.
Yeah, yes,
I could.
Sir. So one system, one system we are talking about. This is from this side, and this has already arrived. So these two systems gathered together, and which has resulted into extreme rainfall over the area. So this is the reason why we have received so much of rainfall in this region in 2 days, right? So topography.
How was the watershed conditions before this particular rainfall event?
Pardon me?
Were they dry? The watershed conditions, were they dry?
Almost dry, sir. Almost dry. Almost dry. Yeah.
Okay. Good. Yeah.
So this has resulted into the heavy rainfall. And at the time of rainfall, what was the situation? This is a very interesting hydrograph that is for Dantiwada Dam. So I hope participants have got idea now that Dantiwada Dam is on Banas River and Sipu Dam is on Sipu River. And from both the dam, it confluences near Deesa. That is 12 kilometers. Deesa is the taluka place which is 12 kilometers downstream of Dantiwada as well as that of the Sipu Dam. Now you look at the condition of Dantiwada Dam on between 23rd and 27th July. You can see that blue line is inflow, and you will see that 23rd up to midnight no flow was observed, and suddenly you can see that the inflow started increasing into the dam, except that except up to 24 midnight, and from 24 midnight suddenly it has taken a sudden like a rocket shoot and reached up to the rule level. The dam has been completely filled within few hours, and the dam authority has no way then release the water. Therefore, you can see the outflow hydrograph. There was no outflow hydrograph. This is almost horizontal, and then suddenly within a very short time period, what has happened? The dam has released heavy outflow into the river from Dantiwada Dam, right? And not only that, the high flow continued for number of hours. It was not that they have opened the gates and then closed the gate after few hours, but they continuously opened the gate and discharge this such a high discharge, which you can see here. It is a cusec, and it comes out to be around 25,000 cusec water, which has been released from the Dantiwada Dam alone. This is one dam. Similarly, at the same time,
I have one question. Sorry.
Yes, sir.
I have one question.
Yeah.
So now that at least you have a forecast of two systems which are coming, at least one system coming towards the area, the low pressure system or depression or cyclone, and they might have some idea about how much water that might drop, what they're not expecting, so that they can release the water early, slowly, or there was no ability to forecast how much water will come into the dam?
No, sir. No, sir. They were not having any idea. Actually, sir, this is a semi-arid region. And when my research scholar, that Nikunj, went to this particular area after this flood event to collect the data, not only the people, but the technical people, those who are engineers and working on the site, they were saying that these kind of events never happen in this area. You are unnecessarily troubling yourself for collecting such data. That was the mindset of the technical people. However, after 2017, it has again not of this magnitude, but the recurrent floods has been happened in the same region, in the same area. So in this case, even if, sir, they have kept the dam empty to receive the flow, but the inflow was so high that they were probably they will not be able to store that much of water in the dam. Because of semi-arid region, always there is a scarcity of water, and therefore the authority always want to save water or want to fill the dam immediately after first rainfall. They even don't want to wait for the monsoon season to complete.
Okay, so I understand. I think they want to make sure that they have enough water, but they don't want to release under uncertain conditions, because if they release in under that conditions, they might not have water for the other people. I mean, for the water supply or
True, sir.
any other
True, sir. True, sir.
uses in the future. So I think, yeah, you are right. Why they have waited till that time. But if
Yes, sir.
they install some kind of rain gauges upstream, like in Mount Abu or some other places, maybe they will have some idea about how much water is going to come in future.
Yes, sir. But actually, the problem is time, sir. You can see here that 24th and 25th, if you will see the inflow hydrograph, that is a blue color line, then you will find that suddenly the inflow has increased. Blue okay. Color line, you just see that. Yeah, so the flow is not intermittent, or flow has not come with 4 or 5 day margin, sir. The rainfall was so heavy.
Minutes, I think. I think it is in minutes. The flow is
in minutes. In minutes. Yes. It's in minutes, right? And the dam authority is not left for any another option than the release, almost open all the gates and release the water from the both the dam. So now what is the, sir, here look at this situation of downstream people. Here you will see that they released 2,25,000, while here they have released approximately 2,50,000. So that is 4,75,000 cusec of water for a river which carries hardly 500 cusec. I mean around 10,000 cusec of water. There, if you are releasing 5 lakh cusec of water, what will happen to the downstream people? And exactly that has happened. And the Deesa, the Talu place, wherein in the town the depth of water was around 2-storied building, and as I have shown in,
might have died.
Yes, sir, 200 people died. 200 people died.
Okay.
And cattle in terms of thousands of number. Moreover, because of semi-arid region and the people who are almost kind of farmer and using floodplains for the farming purpose, they were having their houses on either bank of the river. And it is said that in the midnight, first the water was 30 centimeter depth, and the moment they woke up from their bed, and the water level reached up to their chest level. So there was no time even to run to the higher altitude elevations to safeguard themselves from the floods. So such a tricky situation arises there.
This is more of a flash floods which happen in arid regions throughout the world. For example, in Arizona in US, we think that dry areas will take care of the rain. But what happens is that over the time, the dry areas, the soil becomes so hardened, and then the first rain will dislodge some of the top particles and then go inside and close the soil pores and everything, so that water has no way but to go as runoff. And this happens in Middle Eastern areas also, in desert areas, like it's called wadi hydrology, WADI. There's a name for that.
Yes,
so
sir. Yes, sir. I know.
Common. Yeah.
Yes,
sir.
So
this looks like a similar flash flood event, I think, in an arid region.
Yes, sir. Yes, right? Sir. Yes, sir. Yes, sir.
Okay. Good.
So, looking to this, as I say that the areas was flooded, and moreover the Narmada Main canal, which I have shown in the map, which is perpendicular to it, and the capacity of that canal siphon was hardly, that is 700 meter wide, and hardly it's having 300 cumac. Well, the release discharges in terms of 5 lakh cusec, it was not able to pass the water safely, and because of that, the canal breached for the kilometers of land. I will show you in the next slide that the water passed over the main canal. This Narmada Main canal is partly below the ground and partly above the ground, and the depth of water was so high that it has overtoppled the Narmada Main canal. Right. So 1D hydrodynamic model has been developed using Mike Hydro River. These are the steps for development of 1D model. This is the river network. You can see here, this Sipu Dam, this is the Dantiwada Dam, and this is the Umri gauging station, Kamalpur gauging station, and all cross sections area that we have taken. This is again the chainages, the Dantiwada Dam, Sipu Dam, and all the chainages where here it is a Deesa village. This is the Umri village, and this is the Kharia village where 18 people of one family died in a house. This is the Kharia village, which is very close to that of the Narmada Main canal, and probably due to the crowding effect, because before breaching the main canal, the water probably have sprayed downstream or upstream of it, and it has flooded the villages like Umri, Kharia, and all other villages which are in this particular area up to the depth of around 4 to 5 meters, right? So this is again the cross section is shown. The boundary conditions are given for model development, upstream and downstream boundary condition. For Dantiwada Dam, this is hydrograph. This is again a Sipu Dam hydrograph. And for downstream side, water level at Kamalpur gauging stations were given, and the model has been developed using the mic software. So the value of Manningsand, depending upon the riverbed condition, taken as 0.02. The velocities which we have formed our model was around 5.68 meter per second and 0.07 second. The maximum and minimum Proud numbers 1.6 and 0.312 is observed. The maximum simulated water level at all cross sections with RL of left and right bank and changes has been shown in the next table. You can see here the water level time series, discharge time series, water depth time series, and flood depth size series. This D part is significant from the height of the water which has been passed from the region that has been shown over here. This is the water level profile in the dam. The maximum water level at particular cross section, while water level at given time step, that has been shown using the cross section of mine. The calibration, for the calibration part, we have used various Manning's value, and for that Manning's value, compare the statistical parameters like RMSE, NSE, and R square, and based on that, we have tried to find it out what is the optimum value of and we can use for this particular flood. Then to validate it, we used the another flood data of 2015, and for that also various Manning's values of n and the statistical parameters have been compared, and the flow with time observed, that is blue line is 2017 observed water level at Umri gauging station, and the other one, that is the simulated water level using that of the Mike 1D hydrodynamic model has been worked out. This is the comparison observed at Umri gauging station for 2015 flood. This was for another flood event 2017. For calibration and validation, we have used the data of 2015 flood. These are the various values of simulated and observed water level for two different floods, 2017 and 2015, and work out the value of R square. This table shows the depth of water over the left bank and right bank, where you can see that at 82,619 meter channel, the right bank water level height was 4.36 meter, while the left bank was around 6.017 meter. So you can see here the picture of it. This is a river, and these are the chainages. You can see the chainage are marked over here, and over the left bank and right bank, these are the villages, and over these villages, what may be the depth of water that has been worked out over here on either bank of the river from 1D model. This 1D model is again coupled with, and the critical flood reaches, that also has been identified, right, with the different colors. You can see that after this it becomes a more critical, because this is almost after the confluence, almost a downstream part of the reach, where you can see that entire downstream part becomes a critical river reach, right. These are the number of villages. This is a Narmada Main canal which is passing perpendicular to it, and all these villages we have surveyed, and what was the actual depth in these particular villages that have been compared with the simulated depth of water for 1D model. Then as we have identified the villages also, which are with the cross section, that flood prone villages for at various chainaries critical for it. After developing 1D model, we have gone for 2D hydrodynamic model using Mike 21. And in after preparing the basics we required for developing a 2D model in Mike, we have gone for a simulation of it using these parameters or hydrodynamic module specific parameters, considering the values or preparing LULC map, bed resistance map, structures, because there are few structures. Structure is a Narmada Main canal, which is passing perpendicular to that of the main canal, that has been constructed using Mike software. And the running the hydrodynamic Mike model, we have got the flood inundation, how to validate it. For that, flood inundation questionnaire survey has been prepared, and this is the actual picture of the photograph of the Nikunj, who has visited the villages and collected what was the depth of or what is the highest water level in specific villages. This is the result of coupled 1D 2D hydrodynamic model, wherein you can see that different data types in result files, what you can observe it, and results windows, and how the flood has moved. This is very interesting, Dr. T. I will like to draw your attention, and participants, please pay proper attention that how 1D 2D model can help to find it out what can be the depth of water when there is a obstruction structure like a canal obstructing it, how the water will try to move over it. So you can see that simulated flood inundation depth on 24/7/2017, 12 o'clock, without Narmada Main Canal. A is without Narmada Main Canal and B is with Narmada Main Canal. So if we consider Narmada Main Canal, then and C with bridge Narmada Main Canal. So how the water has spread, if there is no main canal, if you consider, and then the water is moving, when the canal is considered and then the water is moving, and when the canal is bridged and when how the water is moving, that is shown in the picture A, B and C that we have studied. This is again without Narmada Main Canal, with Narmada Main Canal, but this is at 16 hours. Now time is changing. Please pay attention. This is 24/12 o'clock. This is 24/16 hours. And see how the water has spread. Then 24/20 hours. Right? That is night 8 o'clock. Then, yeah, and clearly you can see when the canal is bridged, how the water has spreading. Without canal, how the water is spreading. And with canal, you can see that the spread area and depth is more, right, on the upstream side compared to that of the downstream side. But around this time, as you can see here, if you can see these two pictures, that is 12 o'clock, I think the canal remains intact. But as the time moved, that is 4 o'clock, and after around 8 o'clock, you see a lot of water is there on the downstream side. That means that the canal has breached at the number of locations and the water has started over toppling it. So that is at 20 p.m. This is midnight, 25/7 midnight, and this is the worst time. We have checked it with the actual condition also. As I said, the people said that they were sleeping, and mostly the people were from a poor family. So they were either lying down on a bed, which is hardly having a height of 40 centimeters or 45 centimeters. So they said that around midnight, the water was up to their chest level. So you can see here that A, B and C, A without canal, that is B with canal, and C with the bridged canal. That when the canal has been bridged, what would have been happened on 25/7. This is again the 4 o'clock, 25/7, and the maximum water I think you can see at 25/7, 4 p.m. Right? Then this is 25/7, 8 o'clock of the same day. This is 25/7, 12 o'clock. This is 25/7 again, 4 p.m. That is 8 p.m. 26/7, 00 hours, 4 hours, and then slowly water will start receding after 26/7/2017, 4 p.m. So this is what the comparison of the actual and simulated depth at various locations, right? From the flood survey depth, this is the right bank, the villages which are on right bank, and the simulated depth there, that simulated flood depth. Three scenarios we have considered: that simulated flood depth without Narmada Main Canal, simulated flood depth with Narmada Main Canal, and simulated flood depth with bridge Narmada Main Canal. So, and from questionnaire survey, when we have visited these Devas villages, it has been observed the depth was around 2 meters. And almost for all the cases, the simulated and observed depth matches with each other. So this is again the number of villages which have been served, and on the left and right bank, what are the depth of villages that has been worked out. So this is the Narmada Main Canal, and how the flood depth, simulated flood depth for various villages, how it would have been varied from 24 to that of 27. That also we have tried to work out. That is for different villages: Davas, Kumpar, Golia, Umri, etc. These are the another villages where the flow depth has been shown, simulated flood depth. At the same time, that has been tabulated also and compared with the flood depth from questionnaire survey. So the question here is that this is again the simulated depth for the villages which are affected by the Narmada Main Canal. So that also we tried to identify the which were the villages, and how the water depth has been varied. That has been shown that without canal, you see that yellow color is same village without canal, same village with canal, this one, and same village when breached canal. So with canal, you will see that the water depth has right. So before breaching, the water would have probably reached up to this much of depth, and then afterwards the breaching might have happened and the water level has gone down like this. So similarly, this has been, yeah, and this is the village, Kharia village, where I said that one family's 18% died. This was the worst affected village, because our model also shows that with canal, the depth of water in this village might have reached around 3 meters, while all the houses were kacha houses with tiled roof are not having height more than that of the 3 meters. And these 18 people which were died in one single family, they were all in one house, and probably they may be trying to survive, but the water level has gone more than the height of that particular house, which has resulted into this casualty. So lastly, just I wanted to show you about these are all the villages comparison of, yeah, and this is the map. You can see here that inundation extent, which is shown by the blue line, and the this is what the syphon, canal syphon, that was not sufficient. Actually, it is said that when the Narmada Main Canal was constructed, that time the canal syphon was made of 750-meter width. While the villagers of this region have pointed out to the engineers that this much width of canal syphon may not be sufficient for the flood to pass. You please keep it at least 1 to 2 kilometers. But from the economic point of view or the availability of fund points of view, the passage which has been given for flood water to pass was hardly 700 meter, and that has resulted into what you can say increased depth of water before breaching of this main canal. So this is all about the extreme of rainfall and floods, a case study of Banas River. Thank you very much.
So one small question I have is that if the dam would have not released the water, there is a risk of overtopping?
Yeah, dam would have failed, sir.
Okay.
I think you have seen that hydrograph. In hydrograph already the water inflow they have taken above the rule level.
Okay.
Even they have saved before releasing. Just I will show you that hydrograph. Yes, this one. So this rule level is this line. Can you
yeah,
see?
yeah. Yeah, I can see. Yeah,
Ah,
the green line,
green one is
right?
the rule level.
Yeah.
This is the
Oh,
rule
rule
level.
level.
So even they have stored above it. Right, this is.
Okay.
So here you have FRL 186 meter, while that is a 182 meter.
Okay. Okay.
Okay. Yeah.
For the tomorrow's program, I have one request because for some reason I have a small online meeting with the Kerala. Um, I don't know, the principal scientist of Kerala State Council, uh, Science and Technology Environment. They have called me for some expert comments on their science park they are developing at 15 hours. Sorry, 17 hours. So that means that is 5 o'clock, right?
Yes.
So can you do your presentation earlier and then I will do the next one in the last? Is that okay?
No,
Because I
think
think you have a presentation tomorrow.
Yeah, I will do it 5 p.m. No problem, sir. Hello.
Okay. So
Yes,
I
sir.
will, yeah.
You want to shift the 5 p.m. presentation, na? So 5 p.m. presentation
Yeah,
I will do. That's a tutorial hour. So all the participants are requested to bring calculator, right, during this tutorial class. Okay.
So I will do after your tutorial is finished. Whenever it is finished, I will do the last presentation.
Will do, sir. Will do, sir. Will do, sir. No problem.
Thank
Is
you
there
so
any
much.
question in chat box?
Does this model work in all geological formations? That is the question.
Sir, this model work in all what do you mean by all geological formation? Because already the Banas river originates from hilly region and then it moves to the plain, and in the plain partially it flows from what we can say the normal ground, and then it confluences into the desert. That is the condition of this model.
Now, based on this flood situation and your simulations and also the loss of lives, was there any momentum to increase monitoring in the upstream reaches of Mount Abu or some other place? Is that going on something?
No, sir. What I know is that all the breaches of Narmada Main canal has been repaired. That is number one thing. Number two,
Okay.
that the canal siphon, which was around 700 meter, that to pass more flood water, they have given the barrages. That is SS is in between. So apart from that of canal siphon, they have constructed number of passages for water, that is natural water, to pass without what damaging the main canal. This has been done.
Okay, so for the upstream of the dam, if they have a rain gauge installed there, some kind of automatic rain gauge or some kind of mechanism to know how much rainfall fell, that might trigger a warning, and that can help them to probably release certain amount of water. Not a lot of water, but at least some amount of water.
Yes, sir. Yes, sir. We can say that instead of 5 lakh cusec what they have released, if they have released a little less, and if they have time to release it over a period of time, probably that would have saved the people of downstream side.
Yeah, definitely. Yes, you're right. Okay. Yeah, good.
There is one more question that Tushar is asking. Flow changes smoothly over time, but on this event it was abrupt, and such cases are difficult to predict from past trends. Yes, true. That is true.
Of course. Yeah. It was one of those rare flash flood events.
Yes,
Flash
sir.
flood
Yes.
events are very difficult to predict unless you have. In one of the studies I have seen coming from Middle East, what they have done is they have identified, because they get flash floods very often. It's not like that. Once in a while you get the flash flood. These guys get it every year. So what they have done is to have more distributed dams, in the sense a network of dams trying to absorb the shock of the system. That's what they have tried. So that is one of the research ideas they have tried. But the construction and implementation will be difficult. Instead of having one dam handle the flash flood, they have a series of dams upstream so that the existing water, if at all there's a flash flood, can be diverted. That's what it is.
Hello,
Yeah. Bolo
sir.
Nikunj.
I would like to share one more thing while I was doing
Yeah, please.
questionnaire survey.
Sir,
So when
Nikunj, one minute,
Yeah.
Nikunj. Nikunj is
Yeah.
the one who has carried out this particular research work. And he moved in the river bank of Sipu as well as Dati. He has visited Sipu Dam, he has visited Dati Dam. He has met with the people of both the areas. Yes,
Do
Nikunj,
you have,
what are your
do you have any
inputs?
interesting stories from there?
yes. So like while they have released the water from the dam, they gave information to police to warn the people in the downstream. But they were not knowing that the water could reach to 10 kilometers from the river because of the Narmada Main canal. They were not aware of that. So even though they get the warning, people didn't shift it to higher places because like no one have expected that water would have reached up to that places. That's why they didn't shift it to the higher places, and that caused the higher damage to that area. And that is why we have particularly focused on this Narmada Main canal, that due to this water have flowed in the lateral direction instead of the downstream direction.
Yeah.
So that is the reason.
Very good work.
Even though they have warned the people, they are not believing that this could happen in this area because they have never experienced that kind of thing in the past or in the history.
Yeah, this is the problem in some flood warning systems. Even though we warn the people, people will not take care of that warning seriously. That's the problem.
Yes.
Yeah. Great work. I like the work. Yeah.
Thank you, sir.
You.
So all the participants, please switch on your camera for attendance. Ayushi, I think you are doing this work today.
Yes, sir. I'm taking screenshot. I request all the participants, please turn on your camera.
Yeah.
Thank you, sir. Thank you, everyone.
Thank you. Thank you, Professor Yadav. That was a very good day today with a lot of very interesting. I think you are muted.
Thank you so much.
And it was a great day. We had a good number of experts talking and lots of research ideas and everything. So I hope that all the participants would have benefited from the talks. Tomorrow is the last day. So just a reminder, maybe you can send an email about the switch of the presentations. One is yours is coming early at 5 o'clock. That's all.
Yes, sir. And sir, I have not received the lecture files. Have you dropped in Dropbox?
I'm creating them. I'm creating them because what is happening is I'm doing a lot of other stuff also because next week I have 2 more presentations I am preparing. So,
okay, sir. No issue, sir. Only thing that my Dropbox sometimes become full. So I am asking you that whether you shared and I have not received.
I will directly put it into Google Classroom. I'll try that. If it works, otherwise I will send it. Because the PDFs are smaller, so they won't take more space. Okay.
Okay, sir. Thank you. Good night and bye-bye.
Bye-bye. Good night, all.
Thank you, sir.
Thank you.